magical session with a question. Okay, so let me just ask you one thing. If you add two irrational numbers, is the result still irrational? Oh, think deeper. What if we multiply them? What if we divide them? What if we subtract them? What would be our result? Yes, please understand these basic operations. Yes, you have been using them for life. But how your irrational numbers, your rational numbers, your real numbers, I would say, behave under these operations. So let's unlock the secret. Let's explore together. Are you ready, my number explorers? Let's go. So in today's session, we will be getting the closure, commutative, associative, and distributive properties. These are the properties under which we will observe how real numbers behave, how these properties come in use. And we will operate under rational numbers, under irrational numbers. You will understand each and everything in detail. I just insist you just open your notebooks along with your pen and just get tuned with me. So what are the real numbers? Anybody can tell what are the real numbers? The real numbers are everything on the number line. As you can see, naturals, integers, rationals, irrationals, all are accumulated under a big set that is your real number set. You have been using them for life. Yes, real numbers are everywhere. These whole numbers are known as your real numbers. Now let's apply the properties under real numbers. So yes, these are the basic operations: addition, subtraction, multiplication, division, use of brackets and simplifications. As we already know what is board mass. Yes, B for bracket, D for division, M for multiplication, addition, and N followed by subtraction. So let's just start with our first property. What is that property? Closure property. I just asked you one question, that while adding two irrational numbers, still giving you irrational numbers? That is the question of closure property. If I take two numbers from a set, from a particular set, let's suppose I'm taking two whole numbers. So the result under any operation is coming out to be as whole numbers or not? That is our closure property. Closure property means closed. The set is closed. If I'm taking two natural numbers, if I'm adding them, the result is, yes, the result is still whole numbers. If I'm multiplying them, the result is still whole numbers. Under various operations, the set is closed. So just read out with me, just note it down. If an operation could be anything. It could be addition, it could be subtraction, it could be multiplication, it could be division. If an operation on two numbers from a set means whole numbers, it could be natural numbers, it could be rational numbers, it could be irrational numbers, it could be, the result should belong to the same set under any operation we are taking it. So the result in the same set, the set is closed under that operation. This is the key over here, closed. Let me tell you with an example. So let's talk about rational numbers. I just insist you, my students, just write two rational numbers, any of the two rational numbers, and just add them. Whichever numbers you feel comfortable with, it should be rational one. That is the only condition. Just tell me after adding them, what is the result you are getting. Take any two rational numbers. You can take half. You can take 3/4. Just add them and observe. The result is still coming in fractional form or a rational form, isn't it? So that means that is our result. That means the set is closed under addition. What if you subtract them? What if you multiply them? What if you divide them? But only the condition is, in the case of division, 0 should not be there. Otherwise, that would not be counted as your rational numbers because Q should not be equal to 0. That is very obvious. Yes, that we have understood thoroughly each and everything. So my point is, whatever you are taking under any operations, in case of rational numbers, the set is still under that. That means closure property is satisfied. Let me just take these examples. 1 by 2 plus 1 by 3, giving you 5 by 6. 1 by 2 is your rational. 1 by 3 is your rational. And hence 5 by 6 is also rational. You were adding here, you were getting the result as rational numbers. So the set is closed. Yes, these two numbers were belonging from a set that is your rational numbers, and the result is still belonging to the same set, rational numbers. You can multiply. As you can see, 3 is also a rational number, 3 by 1. You can take any rational number, whichever you are comfortable. You can take 5 by 4, 8 by 3, whichever number you want. You can take, just get it multiply by another rational number. The only thing, what is the thing? The two numbers are from the set, from the same set. I'm taking rational numbers. Two numbers are rational numbers. Whichever operation I'm applying, if I'm adding them, if I'm subtracting them, if I'm multiplying them, if I'm dividing them, the result should belong to the same set. That shows your closure property. Hence, it is proved over here. Yes. These two numbers after adding still giving you rational. These two numbers after multiplying still giving you rational. You can take any numbers that are going to give you same result after subtracting, after getting divided too. Yes or no? So let's just jump to the irrational numbers. What do you understand by that? Do you feel that like rational numbers, irrational numbers too follow this property? Yes, what do you think? Let's take any two irrational numbers, any two irrational numbers. Take them and just let me know. Is the result still giving you an irrational number? Think over it. Take any two irrational numbers. Let's suppose under root 2 plus under root 3. The result is still irrational number or not? Yes, in this case, still it is a rational number, ma'am. So it is getting followed, closure property is followed, but it is always happening that. What if I add under root 2 and minus under root 2? I'm getting 0, isn't it? So the result, the set I was taking, that was irrational numbers, but the result I got is rational number. That means closure property is not satisfied by irrational numbers always. Yes or no? Just write this rule that closure property is not satisfied by irrational numbers always. And you can write down these two examples. Under root 2 got multiplied by under root 2. As these two numbers are irrational numbers, they are under multiplication operation, but the result is coming out as rational number 2. Again, contradiction. Taking two irrational numbers, the result is giving you rational. That means the property is not satisfied. The set is not closed. I was taking irrationals. I am getting rationals. Yes, the set is not belonging to the same set. So you can take these two examples. Hence, you can see not always under these operations closed. Irrational numbers. Should I move ahead? Commutative property. We have done closure property. Closure means closed. Just take two numbers belonging to the same set and check the result under four operations, whether you are getting the result in the same set or not, then your closure property will be satisfied. Now here commutative property. Commutative is nothing but the order. Order does not matter here. How? Applies to addition and multiplication only. Just note it down, addition to multiplication only. I'll show you why not subtraction and division. As you can see that 2 plus 5. Just add 2 plus 5, my dear students. Just add 2 plus 5. What are you getting? 7? Yes. And after adding 5 plus 2, I just flipped the order. 5 plus 2. What is the answer? Again 7. So what you have observed over here, that after flipping the order, the result is not hampered. The result is same. If 2 is added to 5 or 5 is added to 2, same thing. Just reverse the order, but the result is same. Under addition, it is satisfied. Under multiplication, 3 cross 4 gives you 12. 4 cross 3 gives you again 12, because we are adding something. We are multiplying something. What is multiplication basically? Multiplication is accumulated addition. Yes. So we are getting higher and higher. So here order does not matter. Either way, we are getting increased. Yes. But what if in case of subtraction or division? Let's suppose I just subtract 2 from 5. What is the answer? 2 got subtracted from 5. Your answer is 3? No, your answer is minus 3. Yes. Now flip the order. 5 minus 2. Your answer is 3. Is the result same? No, ma'am. The result is not same. That's why under subtraction, commutative property does not work. Now, let's suppose you are getting divided. 2 divided by 4. 2 divided by 4. 1 by 2. And 4 divided by 2. You are getting 2. Is the result same? No, the result is not same again. So only under addition and under multiplication, commutative property works. Please note it down and please remember it for life. Order does not matter under addition or multiplication. What about irrational numbers? I have just told you about rational numbers, 2 plus 3, 3 cross 4. What about irrational numbers? Let's take any irrational numbers. Let's just add them. Under root 2 plus under root 3 would be same under root 3 plus under root 2, isn't it? Yes, the same process we are following. Whether it is irrational one, whether it is rational one, we are just adding something. We are just multiplying something. The result will be same. But in case of irrational 2, subtraction and division does not work. How? Like rationals. As you can see here, a minus b, that means under root 5 minus under root 2. Whatever the value of under root 5 is, whatever the value of under root 2 is, whenever you are subtracting it and after flipping the order, will it be same? No, I have just shown you the method about rational numbers. You are very right. Irrational numbers also are not commutative under subtraction, under division. Clearly, under root 5 minus under root 2 is not equal to under root 2 minus under root 5. Commutativity works for addition and multiplication. Again, it's same in the case of division. Under root 5 got divided by under root 2. Under root 2 got divided by under root 5 will be giving you different results. Hence, commutative property is not satisfied. Should I move further? Just note it down and just write. commutativity, whether it is rationals, whether it is irrationals, or you can say for both rationals or irrationals, it works under addition or multiplication. It's a game of order. Now, the third property is associative property. Associativity, that means grouping. You can just write here, associativity means grouping. Grouping means what? So far, we were dealing with two numbers. We were adding them and we'll be observing closure property. We'll be adding them. We'll be seeing their order after flipping the order, whether it is same or not. Now, associativity works for three numbers. It's a game of brackets, as you can see. Basically, just write along with me 2 plus 3 plus 4. Just write 2 plus 3 plus 4. 2 plus 3 plus 4 to the left hand side and 2 plus 3 plus 4 to the right hand side. The same thing? Is it equal? Yes, same thing I have written in the both sides. Now let's place the bracket. First of all, let's put the bracket up to two numbers. And towards the right hand side, just put the brackets towards the last two numbers. Isn't it? I have put the brackets to these first numbers. Here I have put the bracket to last these numbers. Now just solve them by applying BODMAS. BODMAS says bracket would be opened firstly. 2 plus 3 gives you 5. Then it would be added to 4 is giving you 9. Yes? And here the bracket would be opened firstly. 2 would be as it is. 3 plus 4 is 7. Now 2 is added to 7. So your answer is same. Your answer is coming as 9 in either of these sides. Left hand side is equal to right hand side. So what pattern you have observed? What result you have observed? That associativity works for addition, isn't it? Whether you are grouping three numbers, either way, you are just adding the three numbers. Only the method is different. First of all, bracket is put here. In the right hand side, bracket is put here. But either way, you are just adding. You are just grouping the numbers. So your result is coming out as same. But just read it out. Same goes for multiplication too. 2 cross 3 gives you 6. 6 cross 4, 24. Here, 3 cross 4, 12. 12 2, 2s are 24. Again, the result is same. So what you can say? Like commutativity, associative property also followed by addition and multiplication. Here, same goes with the rational numbers under root 2, under root 3, under root 5, under root 2, under root 3, under root 5. Just put brackets to the first numbers, first two numbers, and just put brackets to the last two numbers. You would observe that the result is same again, isn't it? Now does not apply to subtraction and division. Same thing. Same thing, because under root 2 minus under root 3 would be giving you different results. Over here, under root 3 minus under root 5 would be giving you different result. Same goes with the division part. I hope you are getting it clearly. I just have shown you examples, same examples you can take. You can just switch the sign from positive to negative, from multiplication to division. And you yourself will observe that under subtraction and division, the properties are not going to work. Yes? Same thing, rationals adding up, giving you same result. Rationals multiplying, giving you same result. Irrationals adding up, giving you same result. Irrationals multiplying, giving you same result. Yes? Now, the last property is distributive property. In the associative property, we have dealt with the three numbers. Here also we are taking the three numbers, but with a twist. What is the twist? In the distributive property, we are using two operations. Here, as you can see, multiplication can go along with positive sign. Multiplication can go along with the negative sign too. Yes. How this bracket opens up? A is present outside this bracket. And in this bracket, there are two numbers B and C. So the number present above the bracket, ahead of the bracket, would be taken along with either of them. How? A multiplied by B, one term. A multiplied by C, second term. And these two terms are separated by this plus sign. Same goes with the negative sign here. A multiplied by B. A multiplied by C. And this sign, negative sign, would be put in between them. This is how you open up the brackets. Yes, now observe how this property works. Just write along with me. A multiplied by B plus C gives you A cross B plus A cross C. As you can see the example over here. Let's take this example. 2 multiplied by 3 plus 4. 2 multiplied by 3, 2 multiplied by 4, and then after adding them, giving you 14. How? 2 3s are 6, 4 2s are 8, and 8 plus 6 adding up, giving you 14. Isn't it? That is your distributive property. Goes with the irrationals too. 2 multiplied by under root 3 plus under root 2. Then 2 would be multiplied by under root 3. 2 would be multiplied by under root 2. Yes, distributive property just take the involvement of two signs. It could be negative and multiplication. It could be multiplication and positive. Now, additive identity. What do you understand by this term? Additive identity. Additive means addition. Identity means same. After adding something to a number gives you the same number. What could be that? Additive means addition. Identity means same. How a number could be put same after adding it into something? Only 0 is the number. Yes, after adding 0, you are getting the same number again. So 0 is claimed as additive identity. Just write it. 0 is claimed as additive identity. As you can see, 5 plus adding 0, giving you the same number 5. Under root 2 plus 0, giving you the same number under root 2. So, what is the change over here? What is the bonus? What is the identity? 0 is the identity. Yes? Now, in respect of that, what could be the multiplicative identity? What could be the multiplicative identity? I have just told you what the additive identity is. Multiplicative identity. How could the number be put as same after getting it multiplied with something? In additive identity, we were adding something, we are getting the same number. In the multiplicative identity, we are multiplying it with something to get the same number. Use your critical thinking. Obviously, here is the 1 is the number, 1 is the magical number that does not change the number after getting it multiplied. How? 6 multiplied by 1, the number is keeping as same, 6. Under root 5 multiplying by 1, the number is kept same again. So 1 is the multiplicative identity and 0 is the additive identity. Now let's just revise the additive inverse. Inverse means opposite. Inverse means just reverse it. Inverse, additive. Additive, what is the opposite of additive? Subtraction. Whatever would be your number, just take the negative of that number. Here, as you can see, 7 is the number. And what would be its additive inverse? Yes, just take the opposite sign of that. What is the opposite sign? Negative is the opposite sign. 7 minus 7 giving you 0. Under root 3 minus under root 3 giving you 0. That was your additive inverse. Opposite of additive. Now, in the same process, in the same critical thinking way, can you just tell me what would be the multiplicative inverse? What is the opposite of multiplication? Division. Yes, but how? Multiplicative. Let's suppose you are taking a number 2 by 3. what would be its inverse, multiplicative inverse? That means it would be its reciprocal. How it goes? 4, you are taking a number, its reciprocal would be 1 by 4. 4 multiplied by 1 by 4, the result is 1. Here, 1 by 2. The number is 2 and its reciprocal is 1 by 2, giving you the number 1. So what pattern have you observed here? Whenever you are applying the additive inverse, you are getting the additive identity. Whenever you are applying the multiplicative inverse, you are getting the multiplicative identity. See, multiplicative inverse is applied over here. You are getting multiplicative identity. So that is your proof. Whenever you are doing your sums, if you are getting multiplicative identity, you are going in a right way. Now it's time to do an activity. Let's just summarize. We have observed how different number types behave under operations. Closure property, commutative property, associative property means grouping. 3 numbers are considered, and distributive property. 3 numbers with 2 operations are considered. Then additive inverse, multiplicative inverse. Additive identity, multiplicative identity. Now, based on these things, let me just give you some expressions and you just detect them just like that. Here is the number 3 plus 7 plus 2, 3 plus 7 plus 2. Which property is it? Which property am I using here? 3 numbers are considered and it's a game of brackets. So what would you say? Yes, ma'am, it's an associative property. That's the associative property. Now come to the expression second. Under root 2 multiplied by under root 3 and under root 3 again multiplied by under root 2. What is the pattern I'm applying here? What is the keyword you are observing here? Is the order flipped? That means commutativity. Yes. Again, expression 3, 5 got added to minus 5, giving you 0. What is that? What is that? What is this minus 5 over here? That is your additive inverse. 5 is of positive sign and I'm taking negative of 5. That is its inverse, giving you additive identity. Basically, you are taking a number, take its inverse means negative sign, adding up them, giving you 0. Under root 2 plus 3, what is the result? Still irrational. Still irrational. What do you think? Yes, but not always. In this example, it goes, but in which example it doesn't go? Under root 2 minus under root 2, giving you 0 as rational number. So the closure property is not satisfied. Expression 2, the 2 rational numbers are added up. That's a rational. Rational is closed under 4 operations, but irrational not always closed under these operations. We have to be very vigilant while doing that. I just insist you just try a few examples and just take the help of your amazing teacher if needed. Just breathe in, breathe out, take some rest, and let's meet tomorrow. Take care, my dear students.